Okay, so today we're going to be looking at negative exponents. Now, the other day we did a table in class looking at these exponents. Now, we did a table where we just looked at 2 to the 4th is 16, 2 to the 3rd is 8, 2 to the 2nd is 4, 2 to the 1st is 2, and then we started looking at, are there any kind of patterns? What happens here? Well, we noticed as you moved down, you're actually dividing by 2. Each time you move down, you're dividing by 2. Now, if you remember why we said that happens, because exponents are repeated multiplication. So as you increase the exponent, you're multiplying. But the reverse is also true, that as you decrease the exponent, you're actually dividing, because the thing that gets rid of multiplication is division. So getting rid of an exponent, or lowering the exponent, is actually just like dividing that number. So if we continue this pattern, and we divide by 2 again, then we end up seeing that 2 to the 0 power is 1. Now, we saw that the other day, and we learned that anything to the 0 power is 1. But now we want to take it even further. Okay? What if I look at the next one? The next exponent would be 2 to the negative 1, because I'm counting down by 1, 2, 1, 0. Then it would be negative 1. And on the right, I would be following the same pattern. So I'd have to divide by 2. So when I divide the 1 by 2, I get 1/2, or 1 over 2. If I move to the next one, I have to divide by 2 again. And that's going to give me 1/4. And I can even do it again, and I get 1/8, because half of a fourth is an eighth. Now, this kind of is what was happening when we were walking to the wall. Remember, we were 8 blocks away from the wall, and each step got us halfway to the wall, and then we figured out that we'll actually never get to the wall if each step only takes us halfway. Well, what was happening was each step was smaller. So like one step took us 4, then the next step took us 2, then the next step took us 1, then the next step took us 1/2, then 1/4, and 1/8. So we keep getting smaller and smaller. Okay? So the more negative the exponent gets, the smaller the value gets. Okay, the closer to 0. Alright, now, I do want to look at some of these a little more closely. So, here I have 2 to the negative 3rd power, and that's going to equal 1 over 8. And if I look up here at 2 to the 3rd power, that equaled 8. You should notice something they have in common. Okay? Here you have 2 to the positive 3, and I get an 8. Here you have 2 to the negative 3, and I get a 1 over 8. Okay? So, that tells me that 2 to the negative 3rd power is equal to 1 over 2 to the 3rd power. Since 2 to the 3rd power is 8, and this equals 1 over 8, this equals 1 over 2 to the 3rd power. Okay, this is our basic definition of a negative exponent. Okay, the negative exponent just means that this value belongs in the denominator. Okay, you can see that that actually happens on all of these. 2 to the first is 1 over 2, because 2 is 2 to the first. 2 to the negative second is 1 over 4, because that's 1 over 2 squared. Okay, so the definition of our negative exponent is just that it places that value in the denominator. Okay, that's what negative exponents do. That's the main thing you need to understand for today's lesson. Okay, now another way that we can prove that is using our division rules that we learned yesterday. Okay, dividing exponents. So if we have x to the third divided by x to the fifth, then we can look at what's happening here, and that gives me x times x times x divided by x times x times x times x times x. Okay, and so since I have x's on top and bottom, I can cancel some out. 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom, 1 from the top, 1 from the bottom. Now, this time I ran out of x's on top. Okay, so that means my numerator is a 1 because there's a 1 on top. There's nothing else, just the 1. And in the denominator, I have x times x, which is x squared. Okay, so you can see that 1 over x squared, because looking down here, is the same as x to the negative second power. Okay, because what does a negative exponent mean? That it's in the denominator. So if you have something that's already in the denominator, well, then that means it is a negative exponent. Okay, now using our quotient rule, our division rule, okay, then we're looking at the 3, the exponent in the top, and the 5, the exponent from the denominator, and we have to subtract them. Numerator exponent, the top exponent, minus the bottom exponent. Okay, so we have 3 minus 5, and that's going to give me negative 2. That's why the answer to this problem is x to the negative second power. And you can see that that happens when the x's are in the denominator instead of the numerator. So again, negative exponents means that it's in the denominator. Okay, now the first thing we need to be able to do with negative exponents is to change back and forth from positive to negative or negative to positive. Because there are different situations where you may need a positive exponent or you may need a negative exponent. Alright, so let's look at these two. They have negative exponents, and we're going to change them to having positive exponents. Okay, so I have 2 to the negative third power. Well, since this is a negative exponent, that means this has to go in the denominator. So that's going to be 1 over 2 to the third power. It's as simple as that. The negative does not tell you anything about whether the number is negative or not. The number is never negative unless the base makes it negative. Okay? This is telling you that it goes in the bottom, in the denominator. And that's it. Okay? So this would be this term written with a positive exponent. Okay? Now, this works the same with variables. I have m to the negative fourth power. So, since it's negative, it just goes in the bottom. So 1 over m to the fourth. Now, I want to point out too that when I take this value and put it in the denominator, that the negative sign goes away, because I don't need something to tell me it's in the denominator anymore, because I already moved it to the denominator. So I know it's in the denominator. Okay, so you can't move it to the denominator and leave the negative sign. Okay, when you move it, the negative sign goes away. It becomes positive. Okay, now let's look at going the other direction. Okay, so now we're going to try to change positive exponents into negative ones. So I have 1 over 4 to the second power. Well, as you probably noticed, this 4 to the second power is in the denominator. So that means that the exponent is actually negative. So I can take it out of the denominator as long as I put the negative in the exponent. Okay? It's kind of like an either or thing. They mean the same thing. So you can either put it in the denominator or you can use a negative sign in the exponent. It's the same thing. It just depends on which one you need for that specific problem. Okay? Now, for this next one, 1 over 100. There's something a little different for this one, because there's kind of a rule when you're doing this, and that's that you can't use an exponent of negative 1. Okay? So it'll say that in the directions anytime it's telling you to do something like this, but you will not be able to use x to the negative 1. Now, you may have thought, oh, we could just do 100 to the negative first power because it's in the denominator and it has an exponent of 1. Okay? And although these are equal, we can't use this negative 1 because it's always going to tell me you can't use an exponent of negative 1. Okay? So that's not going to work. So what I'm going to have to do is rewrite my fraction. I know that 100 can be written a different way, using a different exponent other than 1. So I'm going to rewrite it. I know that 100 is really just 10 to the second power. So I didn't change anything, I just rewrote it, because 1 over 100 is the same as 1 over 10 to the second power. Well, now it looks more like this problem over here. So now I can finish, and I can write this, since it's 10 to the second power, but it's in the denominator, it really just means that it's 10 to the negative second power. Okay, so now to reiterate basically what we're doing here is if you change the sign on the exponent, it changes the position of that value. Okay, so if it's in the numerator and you change the sign, then it's going to go down to the denominator. If it's already in the denominator, then it's going to move to the numerator. Okay, now remember, if there is no fraction, like these two up here didn't have a fraction, that means they're on top of the fraction already, because this is just over 1. So if I change this sign, it's going to go down to the bottom. If I change this sign, this is going to go down to the bottom. This one was already in the bottom, so when I change that sign, it's going to move to the top. Okay? Same thing here. When I change this sign, it's going to go from the bottom to the top. Okay, but when I make it go to the top, it's just over 1, so I don't need the over 1. Okay, now notice I didn't say when I make it negative it goes to the bottom, or when I make it negative it goes to the top. I said when you change the sign. So whatever it starts with, if you change this, then it flips to the other side of the fraction. Okay, now here's some for you to practice. Okay, you're going to write each of these expressions using a positive exponent. Okay, so you got 4 problems. Go ahead and work them out, and then we'll work them out together. Okay, the first one is just 3 to the negative 5th power. So since I want positive exponent, since that's what the directions say, I need to change this sign. And if I change this sign, it's going to change the position. Right now it's in the numerator. So if I change this sign, it's going to become in the denominator, 1 over 3 to the 5th. And that's the answer. Same thing over here. It works the same way with variables. Doesn't matter that it's a y instead of a 3 this time. Okay, I have a negative exponent, but I want it to be positive. So I've got to change the sign. If I change the sign, I'd change the position. Okay, right now it's in the numerator. So if I want to change that to a positive 3, I have to put it in the denominator. Okay, now the next one's a little different. Notice that the negative is in the denominator. Well, that's fine. That can happen. Okay, but I have a negative exponent and I want a positive exponent, so I need to change the sign. If I change the sign, I change the position. Okay, so this negative, it doesn't matter that it's in the top or the bottom or where it is. If I change that sign, I change the position. So it's got to go up to the top this time. So this answer is going to be x squared. Okay, now I know that seems a little weird, but yes, 1 over x to the negative 2nd equals x to the 2nd power. Okay, because the negative, if I change this sign, it's going to become positive, and if I change that sign, it has to go to the other side of the fraction. So that gives me x squared. Okay, it doesn't matter that it's positive, so it has to be in the bottom, or if it's negative, so it has to be in the top. No, it can be anywhere and be any sign. Okay, but if you change the sign, you change the position. All right, now, this last one looks a little weird. Okay, and the reason is I've got 2 things here, basically. One of them has a positive exponent already, and the other has a negative. Well, I want positive exponents, so I don't have to do anything to x to the 4th. It already has a positive exponent. But y to the negative 5th doesn't. So I need to change this sign, which means I'm going to have to change the position of just the y to the 5th. Okay? So since this is negative, I'm changing this. I don't need to change the x because it's already positive. Okay, so the y to the negative 5th has to go down to become y to the 5th. So that gives me the answer of x to the 4th over y to the 5th. Okay, so I didn't move the x down because it already was positive. I had to move the y down because it was negative, and I had to change the sign, so I had to change the position. Okay, so when you have a monomial that has more than one variable, you have to look at each variable and decide whether or not it needs to be switched or not. Okay, now for these practice problems, you're going to write each fraction using a negative exponent other than -1. Like I told you earlier, it's always going to say you can't use -1. Okay, so you have these three problems. Go ahead and work them out. Okay, so looking at the first one, I've got 1 over 6 to the third power. This time I want negative exponent, so I have to change this sign. So if I change this sign, I change the position. So this becomes 6 to the negative third power. Okay, I changed the sign from +3 to -3, so I changed it from the denominator to the numerator, and since it's over 1, I don't have to put that part. So I get 6 to the negative third power. Okay. Now, looking at 1 over 25, that's the one where the other than -1 comes into play. Because if I just change it now, I'm going to have a -1. So I'm going to have to rewrite the fraction because there is no exponent yet. Okay, so I'm going to rewrite this as 1 over 5 squared. Now, you're just going to have to be able to recognize the number as either a squared or a cubed or something else. Most of the time it should be something that's fairly easy to recognize, but if not, you may have to use your calculator and try a few things out. Okay, so now I have 1 over 5 squared, 5 to the second power, positive second, but I need it to be negative. Okay, so if I need to change this sign, I need to change the position, which is going to give me 5 to the negative second power. All right, and this also works exactly the same with variables. I need to change this exponent of 5 to a -5, so I need to change the position, and that gives me a to the -5th. Nothing happens differently for variables because remember, they're just numbers as well. Okay. The only thing a little bit different about variables is if you just had the a, kind of like this 25, then there's no way to really change the exponent because you don't know what a is, so there's no way to find out what that is squared or something like that. Okay, so but you won't have to worry about that. There'll always be an exponent, and you just change it just like you did on this one up here. Alright, now, the last thing we have to do today is evaluate negative exponents. Okay, that means actually calculate the answer to these. Okay, now, the first thing I have is 3 to the -4th power. Well, we know what this means because we've already done problems like this in this video. So we have 1 over 3 to the 4th power. Well, my calculator can tell me what 3 to the 4th power is, or I may even know it. 3 times 3 times 3 times 3 is 81. So I have 1 over 81. And I've just calculated this negative exponent. Now, why wouldn't I just go ahead and type it in my calculator this way and put in 3 to the -4th power? Okay? For one, it's going to give you a decimal. And we need an exact answer as a fraction. So we don't want to type in negative exponents. Just type in the positive exponent and put it in the denominator because you know that's where it's supposed to go because it's negative. Okay? Alright, here are some steps that we could look at. Okay, which is what we just did. Okay, the first thing you have to do is you have to write it as a positive exponent. Okay? Then once you write it as a positive exponent, then you can calculate the value of that exponent. Okay? Which is exactly what we just did here. First thing I did was change it to a positive exponent, and then I can calculate that exponent. 3 to the 4th is 81. I just leave the 1 up on top. Okay? So now, let's look at this one. Okay, slightly different. It has a negative, but doesn't really change anything. Okay, I have a negative exponent. I need to write it as a positive exponent. So if I change the sign, I change the position. So I get 1 over negative 2 to the third power. Well, negative 2 to the third power, negative 2 times negative 2 times negative 2 is negative 8. So I have 1 over negative 8. And that's what negative 2 to the negative third power is. Okay, let's try one a little bit more in depth. I have 4 times 6 to the negative second power. Now, remember, is this whole thing being raised to the negative second power? No, just the 6. Okay, if the 4 was being raised to the power 2, it would be in that set of parentheses here. Okay, so this is just 4 times whatever this stuff is. Okay, so I've got to get rid of this negative. I've got to change the position. So that's going to give me 4 over 6 squared. Because the 2 being negative is going to move this 6 squared into the denominator. Okay, so that gives me 4 over 36. Well, that's just a fraction, but I need to simplify it. Okay, so 4 goes into both of these. I get 1/9. Okay, and that's the answer to that third problem. So notice, maybe the last step, if you wanted to add a step 3, you could say simplify the fraction. Okay, but we're writing it as a positive exponent. That's what I did on all 3 of these first steps. Write it as a positive exponent. Notice, it doesn't matter whether the number is positive or negative, but the exponent has to be written as a positive. And then I can calculate the answer from there. And if I need to, simplify. Okay. Now here's some for you to try. You need to evaluate these negative exponents if a equals negative 2, m equals 4, and n equals 3. Okay, so we have some letters here, but they're not really variables because I'm telling you what they are. So this a right here is really just a negative 2. This m is really just a 4. That m's a 4, and that n is a 3. Okay, so all you have to do is plug those numbers in and calculate those values. Okay, so let's look at the first one. The first thing I'm going to do is just plug in my value that I know. So I have 4 times negative 2 raised to the negative 5th power, since a is negative 2. Alright, now I'm going to follow my steps that we just learned. I need to make the exponent positive. So if I change the sign, I change the position. So that gives me 4 over negative 2 to the 5th power. Well, I know negative 2 to the 5th power. That's negative 32. So I have 4 over negative 32, so I can simplify, and I get negative 1/8. Okay, and the next one, okay, again, need to make the exponent positive, so change the position. Well, first I need to plug in my value. So since m is 4, I have 4 to the negative 2nd. So now I need to make it positive, and I get 1 over 4 squared, which is going to give me 1 over 16. So that's the answer to that one. And then for the last one, again, plug in my values first. So I have 6 times 4, because m is 4, times 3, because n is 3, raised to the negative 4th power. Now, again, the 6 does not have a negative exponent. The 4 does not have a negative exponent. Only the 3 has a negative exponent. So that's the only one I'm going to have to change the sign. So that's the only one I'm going to have to change the position. Okay, so I'm still going to have 6 times 4 on top where it is already, and then I move the 3 to the 4th power to the denominator. Okay, now I know that 6 times 4 is 24, and I know that 3 to the 4th power is 81. So then my last step is just to simplify. So I recognize that 3 goes into both of these. So 3 goes into 24 8 times, and 3 goes into 81 27 times. So that's my answer to the last one. Okay, so today we've worked on changing from positive to negative exponents. Okay, and we've evaluated negative exponents. Okay, now to do that, you have to understand what a negative exponent is. It just means to change the position from numerator to denominator, or from denominator to numerator. Wherever it is, you're going to change the position.